Now let's look at further with the string, string buffer and the wrapper classes. The string and the string buffer class. The string class is known as a non-mutable class, whereas string buffer is a mutable class. Now what do I mean by mutable or non-mutable? Mutation means that which can change. So non-mutable means that which cannot change. That is, once you create a string object and provide it with a value, you cannot change the value of that string object. That's why it's called non-mutable. Whereas string buffer object, you can change its value. How do you therefore work with a string class? You can create a string object in two ways. Either by declaring a variable and initializing this variable with a value. So let's say hello. Or the second way is by creating an instance of a class. String s is equal to new string of hello. So these are the two ways of creating a string object. Now let's assume that you want to create another string object similarly using both of these methods. Now again we say string s2 is equal to hello string s2 is equal to new string of hello. Now the question is, what is the difference between these two methods? Now in case of the first method, where you are saying string s is equal to hello, this particular string memory allocation would be done in a free pool of memory, that is in the method area. Whereas in case of the second method, since you are saying new string, the memory allocation for the string is made on the heap area. Now when you create another string object using the first method, and if that string happens to be a string which you have already created, then what happens is it does not bother creating another memory space for that string. Rather, both s and s2 will end up pointing to the same memory location. So in such a case, if you were to compare two strings to see whether both the strings are equal, if you were to compare by saying s is double equals s2, you get true. Because what am I comparing here? I am comparing the address, not the content. And here in this case both happen to be pointing at the same memory location, so it will return true. Whereas in the second case, although it's the same string that I am creating a memory space for, I get two different memory allocations for both of them. So I have for s one memory allocation where hello is stored, and for s2 another memory allocation where hello is stored. So in case of the first method, s will be pointing to where hello is being stored, and in the second case as well it would be pointing to the same memory location. So in the second methodology of creating a string instance, if you were to say s double equals s2, it would return false, because there are two different memory allocations. The addresses are two different addresses for s and s2. Going back to the garbage collector, I think we did not mention that a garbage collector not only works on the heap memory, but it also works on the method area. Method area can be expanded or contracted as and when required. This is taken care by the JVM. So the classes as well as any other memory allocation that's done in the method area are also garbage collected when they are no longer required. Now coming back to the string again. So that we have learnt that there are two ways of creating a string object and what is the difference between them. Now let's look at what happens if I were to try to change the content of a string object. Let's say I have created a string object either using one of the methods. Let's assume that we have string s is equal to hello. Then we want to attach world to this hello, so we might say string that s plus is equal to world. And if we were to display, we still get hello world. But we said string is a non-mutable class. Once assigned a value, you cannot change the value. But here I am showing you to change the value of string s. So what exactly is happening? When you try to change a value of a string object, internally the JVM, what it does is it creates a string buffer object. Now the string buffer class has methods like insert, replace, append, etc. So in this case what's happening is we are attaching to hello the world string. So the string buffer object is created with the content hello. So you got a string buffer object. To that you want to add world, so that is append. So on this string buffer object you invoke the append method. Append world. So now you got a new memory allocation for the string buffer where hello world is stored. This has to be stored back into the string object. Now how do you convert string buffer into a string? Now going back to the object class, there is one more method in the object class called toString method. This toString method returns a string object for any object. So that's the toString method which we need to call on the string buffer object so that we get a string object out of it. By default the implementation of the object class string method is to return some address space. But this method would be overridden in every class to return the state of that object, the contents of that object. So in this case on the string buffer object we will invoke the toString method. This will return a string object and that string object reference is stored into s. So what is happening here? Initially when you created string s is equal to hello, s was allocated some memory space to point to a memory space where hello was stored. Now once you said s plus is equal to world and the JVM executes this, it has created a new memory space where hello world is stored and that space is returned to s. So s now would no longer be pointing here, rather it would be pointing here. So who is pointing to this memory space? No one. So this would be garbage collected when the garbage collector executes. So if you are going to create a string object and manipulate on a string object again and again, do not use directly the string object to manipulate, because every time you would end up creating extra memory locations. Rather use the string buffer object to manipulate and then put it back into a string object. Otherwise there would be a lot of memory wastage.